we'll find the volume in the first octant bounded by these guys. And with these kinds of questions, it helps to be very methodical in how you set things up. Okay, so we'll give a little bit of a sketch of what this thing looks like, and that'll suggest to us what bounds we should pick. Right, so we want to be in that first quadrant where everything's positive, and now we want to find the points of intersection with the axes. This is x, y, and z. We can pick that to be our intercept with the x-axis. So we set both of these guys to 0. X has to be 1. We want our intercept with the y-axis. We set both of these guys to be 0. Okay, and here we set x and y to be 0. So that is 1. So we're looking at this kind of pyramid thingy. It's a little bit thinner in one direction than the other two. We want to get its volume. Okay. Right, so once we've got this diagram, we want to figure out where in the xy plane to be integrating. Right, so we've got these 2 points in the xy plane. And then our region lives above that triangle, so it's sort of a pyramid over top of this region. Okay. And it's often been helpful for us to have the equation of the hypotenuse, the equation of the bounding curves. So we get this line here is x plus 2y is 1. Okay. And now we can set up our integral that'll calculate the volume for us. A bunch of things to figure out. The first is the x bounds. Right, so we want to cut our region like this. So x will run from 0 to 1. And then y will run from y equals 0 up to that slanted line there. height of the function that we're integrating, so the height of this pyramid above the base. Get something like that. So the key step here is, once you've got the region in space, you pick a plane that you want to integrate on. Usually we pick the xy plane. Draw the projection onto the xy plane. Figure out the bounding curves. Use those to set up the bounds, and then integrate height. Yep.
It's always using that sense that it's to the.
Sure. Yeah. You can always project onto xy.